Hello students, today we are going to start from solved example number 3. Already we have finished till second example and we are going to continue further remaining solved examples. Sorry. So in this session we shall see the solved example number 3, 4 and if possible fifth one, and some remaining example would be covered in the next session. So first of all, let us see uh, what is the given example over here. ABC is an isosceles triangle in which AB and AC are equal. You are looking at the bottom, one triangle is given to us. The name of triangle is ABC, and in this triangle the two sides AB and AC are given equal. Now further they are extending the line BA up to the point P. Okay, you can see this one of the side of the triangle ABC, they are going to extend till the point P, and similarly from the point A, means from the vertices A, they are drawing one line which is called as AD. But AD is not a simple line. AD is a bisector of angle PAC. You look the angle PAC in a proper manner. This is the angle PAC they are talking about. This angle PAC, this angle they are going to bisect. Okay, so here we can say that one more thing is given to us, that CD is parallel to AB. So total three things are given. One, side AB and side AC are equal. Second one, the angle PAC is bisected by the side AD. Third one, the CD is parallel to AB. Okay, three things we have given to us. Then we have to show that angle DAC and angle BCA. DAC means this angle they are talking about. This is DAC, and BCA means this angle. So these two angles we need to show equal. Okay. Now, and one more thing we have to show here, ABCD is a parallelogram. Okay. So let us see how we can prove it. Here we shall use one old fact that is known as exterior angle property, or sometimes we say that remote interior angle theorem. So first let me write down the given, then that theorem I will explain to you, and then we shall continue the further solution. First we shall write down, in triangle ABC, we can say that first of all AB and AC are given equal, one thing, and second thing we have given that AD bisect exterior angle PAC. So what I am doing here, I am giving the name of these two angles, angle 1 and angle 2. So I am writing in place of that whole line, angle 1 is equal to angle 2. The meaning is same only. If AD is bisecting angle PAC, means it is making two equal parts, and hence we can say that angle 1 and angle 2 will be the two equal parts, they will be equal. And the third thing we have given here, CD is parallel to AB. Okay, this is our third thing. Now what we need to prove, that we will mention here. So to prove, in to prove section it is clearly mentioned, the first part is we need to write down, we need to prove here angle DAC is equal to angle BCA. That is the one thing. And second thing we need to prove here, ABCD is a parallelogram. So that we will mention here. ABCD is a parallelogram. Now let us see first. Let us see the proof over here. Before I start the proof, first I will explain to you the exterior angle property, or sometimes we say that sorry, remote interior angle property. Suppose this is a given triangle to us. Okay, so I am not able to draw properly. So since I am just explaining you roughly, because the theorem already you know it very well. So suppose this is a given triangle, and in this triangle if I extend the base up till some length, suppose this triangle name I have given PQR, okay, and this point if I give the name as point M. So observe this angle PRM will be called as the exterior angle, okay, because it is coming outside the triangle, and this exterior angle is always equal to the sum of two interior opposite angle. You observe the angle I marked with the double line, that two angles are interior as well as they are opposite to the exterior angle, angle PRM. So we can say that here what equation will be formed? The equation is going to form, we can say that angle PRM will be equal to angle P plus angle Q. So this theorem we have covered in actually chapter number 6. So you may be forgot the theorem over here. So once I have explained you. Now this theorem we have to use it in this question. Okay. So let us see how we can use over here. First of all, let me rub this one and then we can start the proof. These examples are very ideal and little bit difficult also. Okay. So these examples may come in the examination for 3 to 4 marks. So let us see now how we can start the proof over here. First of all, you see angle 1 and angle 2 are given equal. So first we'll mention since angle 1 is equal to angle 2 and since both are equal, I am supposing them equal to y. Okay, here we can write the reason given that are given in the question. Okay, if I further extend, so observe, we can say that since angle PAC is equal to angle 1 plus angle 2, that also we can say because angle 1 and angle 2 both are the part of angle PAC, and if you join angle 1 and angle 2 it will form the angle PAC over there. But now angle 1 and angle 2 how much I have, that is y and y, so that we will write down here y plus y. So we can say that therefore angle PAC will be equal to 2y. Okay, that is the one result we got over here. Now one more thing we have given in the question, in triangle ABC, in triangle ABC we have given that AB is equal to AC, that is given in the question. Okay, that we have mentioned also in the given, you can check that in the given we have mentioned AB and AC are equal. Now if AB and AC are equal, we know it very well by the isosceles triangle theorem. If in a triangle two sides are equal, then the angle opposite to them will be also equal. So here angle B and angle C will be equal. So that two angles I am supposing as angle 3 and angle 4. Okay, so here we shall mention angle 3 is equal to angle 4. So therefore we can say that angle 3 is equal to angle 4. Reason we can give here, angles opposite to equal sides. Okay, and both the angle I am supposing equal to x. Okay, as we have supposed angle 1 and 2 y, so here I am supposing as x. Now see, we shall apply the exterior angle property as I have told you. Look at the figure very carefully. Observe, we have triangle ABC. Now please do not consider a side AD and side CD, that you leave it for some time. So observe the side BA we have produced till the point P. Okay, so angle PAC will be your exterior angle. So angle PAC is an exterior angle and it will be equal to the sum of two interior opposite angle, that is angle 3 and angle 4. Observe, angle 3 and angle 4 are just opposite to the angle PAC. So here we can write down this statement over here. So we will say further, now in triangle ABC, angle PAC is an exterior angle. Angle PAC is an exterior angle. Therefore we can say that therefore angle PAC will be equal to angle 3 plus angle 4. Okay, here how we can say exterior angle theorem. Exterior angle theorem that we have covered in chapter number 6 already. So again, if you have any confusion in this theorem, we can go back and see in chapter number 6. There I have explained in detail. Now angle PAC you observe that is we have 2y, and angle 3 and angle 4 both are equal to x and x. So angle PAC is equal to 2y, that I am supposing equation number second. This I am supposing equation number third, and first equation I am supposing where I have supposed angle 1 and angle 2 is equal to y. So this is my equation number 1. Okay. Now further 2y will be equal to x plus x. Here we can write down by equation second and third. By equation second and third. So here we can say that 2y will be equal to 2x, because x and x if you add will become 2x. 2 and 2 if I cancel, so I can say that I am getting here x is equal to y. Now x I can replace by angle 3 or angle 4. Okay, you can see in the third equation value of x is either we can replace by angle 3 or we can replace by angle 4. So for that I am taking angle number 4. The reason I will tell you afterwards. So x I am replacing by angle number 4. Okay, so this I am replacing by angle number 4. Similarly, y I am replacing by angle number 2, because again for y I have two options, angle 1 and angle 2. So here I can write down the reason again by equation first and third. Okay, so this is one result we got here, angle 2 and angle 4. Now observe the angle 2 and angle 4 in the figure given to us. See why I have taken angle 2 and angle 4, because you observe angle 2 and angle 4 are forming alternate angles onto the side AD and BC. Look at the side AD and BC, and AC will be the transversal. So observe angle 2 and angle 4, they are perfectly forming the alternate angles. And we know that if alternate angles are equal, lines will be parallel. So here which lines will be parallel? AD and BC will be parallel. Okay. So let us write down further. But these are alternate angles. But these are alternate angles. These are alternate angles. Therefore, we can say that AD is parallel to BC. Okay, now see, AD and BC are parallel. Achha, one thing we forgot over here, that first part, what we need to prove? Observe, in the first part, they said to us, prove angle DAC. So observe, angle DAC is our angle number 2 only. Okay, and second is angle, sorry, 1 second I will show you. And second one is angle number 4, that is angle BCA. Observe, DAC is required to prove equal to angle BCA. So that is angle number 4. So angle 2 and angle 4 is actually angle DAC and angle BCA. So that already proved over there, just we forgot to mention. So here we will write down, or angle DAC is equal to angle BCE. Okay, and here you can say proved first part. Now we shall go back to the second part over here. So first part proved first part, and now we shall talk about the second part. So see, we have proved up till now AD is parallel to BC, and also we have given that what we have given here, C given, we have CD is parallel to AB. CD and AB are parallel. So we can say that both the pair of opposite sides are parallel. Therefore, it is a parallelogram. So we can say ABCD is a parallelogram. Okay, so this will be completing the proof of the question. So here we can say that proved second part. Okay, how we have proved ABCD is parallelogram? Because AD and BC are parallel, that we have proved, and remaining remaining one pair of opposite side is also given parallel, that is CD and AB. So since both the pair of opposite sides are parallel, hence it will be a parallelogram. Okay, now let us see the next question. Next example I am taking here, solve example number 4. Yes, solved example number 4 is given as two parallel lines L and M are intersected by a transversal P. Show that the quadrilateral formed by the bisectors of interior angles is a rectangle. See what they have done, they have drawn the bisectors of the interior angles. Okay, who are the interior angles? Those who come between the parallel lines. So for example, if I talk about one of the interior angle, that is angle PAC, that is one interior angle, and its bisector is drawn, the name is given here as BA. Similarly, you observe CAP, sorry, ACQ. ACQ is one another interior angle, and its bisector is drawn. The name is given here as CB. So CB is the bisector of the interior angle QCA. Okay. Similarly, the another two interior angles are given on the right side, and its bisectors also drawn. And the bisectors are intersecting in such a way it is forming one quadrilateral. The name is given here ABCD, and this quadrilateral we have to prove it is a rectangle. We know that any rectangle can be called as a any quadrilateral can be called as a rectangle if its all four angles are 90 degree. So here, since ABCD is forming a quadrilateral, to prove it is a rectangle, we need to prove only one thing, its all angles are equal to 90 degree. So let us see how we can prove it. First of all, we shall write down the given things, what we have given in the question. Observe, we have given that two lines L and M, and L and M are the intersected by a transversal line, and they are parallel also. So we can say that the main given is L is parallel to M. Second, we have given that AB, then CB, then CD and AD are bisectors of respective interior angles. Okay, so we can say that they are the bisectors of their respective interior angles. Now what we need to prove here? We need to show that ABCD is a rectangle. So here we shall write down in to prove ABCD is a rectangle. As I told you, to prove it is a rectangle, we need to show that its all angles are equal to 90 degree. Okay, so let us see the proof of the question. First of all, here I am supposing the name of the angles as angle 1 and angle 2. Two angles I am supposing here as 1 and 2. This angle I am supposing 1, and adjacent to that this angle I am supposing to angle number 2. Similarly, this angle I am supposing angle number 3, and this angle I am supposing as angle number 4, and along with that this angle I am taking as 5 and this angle I am taking as 6. These 6 angles we will be required. Now see, AB is the bisector of interior angle PAC. So angle 1 and angle 2 will be equal because AB is bisecting the angle PAC into 2 equal parts. Okay, so angle 1 and angle 2 will be equal. In the similar way, 3 and 4 will be equal, 5 and 6 will be equal. Okay, so here we shall write down, since AB, CB and AD. Okay, we don't require CD over here, so we are talking about these three only. Are bisector of interior angles. Therefore, angle 1 is equal to angle 2 is equal to, we are supposing here, x. Okay, and one more thing, you observe angle 1 and angle 2 will be the half of which angle? Angle PAC. So we can write down, and angle 1 is equal to angle 2 is equal to half of angle PAC. Okay. Now similarly we can say angle 3 is equal to angle 4 is equal to, we can suppose, y, and angle 3 and angle 4 are equal, but they will be half of one of the interior angle, that is QCB. So half of angle QCB. You need to look the figure very carefully because some vertices, some points are given in a congested manner. Okay, so here you need to see it very carefully. You see Q is coming on one of the end, then come to C and then go to B. So here, sorry, QCA should come. So here I have done mistake. QCA should be taken here. So observe QCA. QCA is one of the interior angle and PAC will be the other interior angle. Okay. QCA. Observe clearly, it is one of the interior angle. Now, see, we have given that L is parallel to M. So we will write down further, since line L is parallel to M. So therefore, angle PAC plus angle QCA will be equal to 180 degree. Here reason can be given, interior angles. Interior angles. Okay, how we can say they are interior angles? Once you check properly angle PAC and angle QCA. Okay, for that you need to forget some time that quadrilateral is formed in between that. Only take these two lines. See, if I take these two lines over here like this, and this will be a transversal. So observe, here somewhere the point is given P, here it is given A, okay, then here it is given C, and here somewhere the point is given Q. So these two are interior angles. Okay, now you can observe very clearly P, A, C and Q, C, A. These two are the interior angle, and we know that if lines are parallel, then interior angles are always supplementary. Okay, so here we can write down their sum as equal to 180 degree. Now further we'll go. Here you observe angle PAC and angle QCA will be equal to 180 degree. But if I multiply by 1 by 2, so here I am going to multiply by 1 by 2 on both the sides. So suppose if I multiply by 1 by 2, so it would be half of angle PAC plus half of angle QCA is equal to 1 upon 2 into 180 degree, because we have to multiply everywhere. Here 2 and 180 can cancel, so this will be 90 degree. Now half of angle PAC, observe, half of angle PAC will be angle 1 or angle 2, and both are equal to x over here. So half of angle PAC I am writing x over here, and half of angle QCA I am writing y is equal to 90 degree. This I can suppose equation number 1, and this I can suppose equation number 2. And here I can write down by equation first and second. And this I am supposing equation number third. Now look at the figure again. Now we have one triangle in the figure. The name of triangle is ABC. You look at the left side. Triangle ABC is one of the triangle over there. However, on the right side we have another triangle, but we are considering right now triangle ABC. And in this triangle you observe one angle is angle number 2, second angle is angle number 4, and the third angle is, we can say, angle number B, or you can say in a proper manner, that is angle ABC, right? So here we shall write down the sum of all three angle will be equal to 180 degree. Once again check which angle I am talking about. 2 is one of the angle in the triangle ABC, angle 4 and angle number B. So now we shall write down further, in triangle ABC, in triangle ABC, angle 2 plus angle 4 plus angle B, and in short I am writing as angle B only, is equal to 180 degree. Angle sum property of triangle. The reason we have given here angle sum property. Okay. Now angle 2 you observe in equation 1 and equation number 2. So sorry, angle 2 you observe we have taken as x, and angle 4 we have taken as y. So angle 2 and angle 4 we shall replace it by x and y. So this will be x plus y plus angle B is equal to 180 degree. This we can say by again equation first and second. Okay, now x plus y is equal to 90 degree. Look at the equation number third. So in place of x plus y we can write down 90 degree, and 90 will go on that side. So value of angle B we will get here 90 degree, because 90 will subtract from 180. So we can say that therefore angle B is equal to 90 degree. So see, out of the 4 angle we got here one angle as 90 degree. Now further we shall write down similarly angle D can be also shown as 90 degree. Observe, angle B is coming on the left side, so angle D is coming onto the right side. So in the similar way, if I take, I can show similarly angle D is also 90 degree. Now two angles are remaining, that is angle A and angle C. So angle A and angle C also we need to show they are equal to 90 degree each. Here also we shall apply the same fundamental, that any one angle, either angle A or angle C, we shall prove 90, and we'll write down similarly the another angle, means angle C, will be also 90 degree each. So here let us see how we can prove the angle A is equal to 90 degree. See, already we have angle 1 and angle 2 are equal, and its value we have supposed by x and x. Similarly, since AD is also the bisector, so we can say that angle 5 and angle 6 will be equal. So that we will mention first. So here further we shall write down, since AD is the bisector of interior angle. Name we will see which interior angle we are talking about. So here AD is the bisector of interior angle, angle SAC. You can check the angle properly. Okay, so angle SAC will be the interior angle who is bisected by line AD. Interior angle SAC. Sorry, here interior angles I have written. Interior angle SAC. So we can say that therefore angle 5 will be equal to angle 6 will be equal to, now I am supposing they are equal to Z. Okay, and one more thing, since both are equal, so they will be half of angle 5 is equal to angle 6 will be equal to half of angle SAC. Okay, and this I am supposing as equation number 4. Now see the figure carefully. In the figure you observe, now I am getting 4 angles. Angle 1, angle 2, angle 5 and angle 6. This all 4 angles are coming onto the line L, and we can say that these 4 angles are forming the linear pair. So here we shall write down further angle 1. Now angle 1 plus angle 2 plus angle 5 plus angle 6 will be equal to 180 degree. Reason can be given here as linear pair. Okay. Now angle 1 and 2 both are equal to x and x, and angle 5 and 6 both are equal to z and z is equal to 180 degree. Now x and x are equal, they will be added, it will become 2x, and z and z we can add, that will become 2z is equal to 180. Now here, sorry, here I forgot, we can write down by equation first and fourth. That reason we forgot to give equation first and fourth. Okay, now 2 we can take common here, remaining will be x plus z is equal to 180 degree, and from 2 180 we can cancel, that will be 90 degree. So we got here x plus z is equal to 90 degree. Now see it very carefully, how we can say we got the value of angle A as 90 degree. Observe carefully. See, angle 2 plus angle 5. This is actually angle A, we can say. Okay, and angle 2 is here x. We can say angle 2 will be equal to x, and angle 5 will be equal to the z. So x plus z, if I say I got 90 degree, I can say that angle 2 plus angle 5 I got as 90 degree. So here we shall write down, or we can say angle 2 plus angle 5 is equal to 90 degree, or angle 2 plus angle 5 will be angle A is 90 degree. Similarly, we can write down, similarly angle C will be also 90, that we will show. Okay, so now here we can say that all 4 angles are 90 degree now. So we can say therefore ABCD is a rectangle. Remaining 2 angles which we have left, actually if you follow the same procedure for that angle, you will get that angles also 90 degree each. So that we can write down as similarly. For example, angle A we have shown 90 degree. Similarly, definitely in the same way, we can show angle C will be also 90 degree. Now let us see quickly today's last question, that is solved example number 5. See, here we have given that show that the bisectors of the angle of a parallelogram See, in that they have taken the bisectors of interior angles of the parallel lines. Okay, here they have taken the bisectors of the angles of a parallelogram, and that bisectors is again forming one quadrilateral. The name of that quadrilateral is PQRS. Okay, and this quadrilateral PQRS is required to show as rectangle. So here also the condition will be same, that PQRS all angles will show as 90 degree. First of all, in the given, we shall check what we have given here. ABCD is a parallelogram, that is we have given here. Second thing, we have given that the bisectors of angle A, B, C and D are intersecting at some points and they are forming the quadrilateral PQRS. Okay, so here we can say that AP, one line, second is PB, third one is CR and DR. These four are bisectors of angle A, B, C and D respectively. Okay, you can check, these are the only four bisectors. Now what we need to show here? We need to prove ABCD is PQRS is a rectangle. So PQRS is a rectangle, that we need to prove over here. Okay, now let us see how we can prove it. First we shall mention in the proof. Okay, first you see, I am supposing this angle as angle number 1 and this angle as angle number 2. Same way I am supposing this is angle number 3 and this is angle number 4. So observe, DR is the bisector of angle D. So angle 1 and angle 2 are equal. Similarly, AP is the bisector of angle A. So angle 3 and angle 4 will be also equal. So first we'll write down, since DR and AP are bisectors of angle D and angle A respectively. So we can say that therefore angle 1 is equal to angle 2 is equal to half of angle D, equation number 1. And same way angle 3 is equal to angle 4 is equal to half of angle A, that is equation number 2. Okay, now further if we go, first of all you see, since ABCD is a parallelogram, it is given in the question, so we can write down, since ABCD is a parallelogram, therefore you know that the side opposite to each other in a parallelogram are parallel. So we can say that AB and CD are parallel, and if AB and CD are parallel, then angle A and angle D will be the interior angles and their sum will be equal to 180 degree. However, we know that in a parallelogram, the angles which are not opposite to each other, means the adjacent angle in a parallelogram are always having the sum 180 degree. So here we can say angle A plus angle D will be equal to 180 degree. Here reason we can give adjacent angle of parallelogram. Adjacent angles of parallelogram will have always some 180 degree. Who are called as the adjacent angle? Which are not opposite. Okay, now I will multiply by 1 by 2. So here we shall write down multiply by 1 by 2. So if I multiply by 1 by 2, so half of angle A plus half of angle D is equal to half of 180 degree. Everywhere I have multiplied, here cancelled. Now you observe half of angle A and half of angle D. Which should be taken? Which are coming inside one triangle. Observe one triangle is there. The name of triangle is DSA. Look at the triangle DSA. In that angle 1 and angle 3 is coming. So we shall write down half of angle D is as angle number 1 and half of angle A as angle number 3. So this will be angle number 3 and this will be angle number 1 is equal to 90 degree. Here reason can be given by equation first and second. Okay. So here this we got as angle 1 plus angle 3 as 90 degree. This is our equation number 3rd. Now look at the triangle DSA. DSA, this angle I am supposing as angle number 5. Okay, DSA, that angle I am supposing angle number 5. So observe in triangle DSA there are three angles, angle 1, angle 3 and angle 5, having the sum as 180 because by the angle sum property. So now further we shall write down in triangle DSA, in triangle DSA, angle 1 plus angle 3 plus angle 5 is equal to 180 degree. Here reason we shall give angle sum property. Now angle 1 plus angle 3, as per the equation number 3rd, we have 90 degree plus angle 5 is equal to 180. Here you can say by equation number 3rd, okay, and 90 will go on that side. So value of angle 5 we shall get as 90. Also now look at the angle 5 and the angle in front of that carefully. So see angle 5 and this angle I am talking about, this angle is actually angle number S. Actually angle 5 is also called as angle S, but angle S we are taking as an interior angle of quadrilateral PQRS. So angle 5 and angle S, you observe carefully, both are vertically opposite angle and hence they will be equal. So now further we shall write down also angle 5 is equal to angle PSR. I am writing the full name of that. So here reason can be given vertically opposite angles. So here we can say angle PSR is equal to 90 degree, or we can say in short angle S will be equal to 90 degree. As we have proved in the previous question, one angle if we are proving 90, in the similar basis one more angle we can prove it as 90 degree. So in front of angle S you observe angle Q is coming. So same way angle Q will be also proved as 90 degree. So here we can write down similarly angle Q will be equal to 90 degree. Similarly angle Q is equal to 90 degree. Now only two more angles we need to prove as 90 degree. Actually one is only required, one we shall write down similarly. So now for that I am taking this angle as, see this angle I am taking as angle number 6 and this I am taking as angle number 7. Again PB is the bisector, so 6 and 7 will be equal. So here we shall mention PB is the bisector of angle B. Therefore angle 6 and 7 equal and they will be half of angle B. So here we shall write down further, since PB is the bisector of angle B, therefore angle 6 will be equal to angle 7 is half of angle B. Okay, and this equation we can give as equation number Now again one more thing you observe, since ABCD is a parallelogram, so we can write down again angle A plus angle B is equal to 180 degree, because they are also adjacent angle of parallelogram, and we know that the adjacent angle of parallelogram are always having some 180 degree. Similarly, if I multiply by 1 by 2, so 1 by 2 of angle A plus 1 by 2 of angle B is equal to 1 by 2 of 180 degree. If I do in the similar way, here again 2 and 180 I can cancel. So we will get here 90, and half of angle A. See, we have two options actually for half of the angle A. Look at the figure. And who is the half of angle B? See, we have two options over here. Angle A half is 3 and 4. We shall select here 4, and similarly angle B we shall select here angle 6, because both are half. You can write down either 6 or you can write down 7. Similarly for angle A you can write down 3 or 4, but we are taking 4 and 6. That reason I will tell you afterwards. So here we will take it as 4 and 6. So half of angle A I am taking as angle 4, and half of angle B I am taking as angle 6, and this can be given by equation first and 4. Okay, so 4 and 6 we are getting as 90 degree. That's sum. Equation number 5. This question is lengthy, but we can't do anything. Such kind of question can come for 4 marks in the examination. Now look at here one triangle. Okay, look at the triangle APB. Okay, this triangle I am talking about, A, P, and then B. This triangle you need to see. Now you see in this triangle, one angle is angle P, second is angle 4, and third one is angle 6. Okay, so we are taking the sum of these three angles, 4, 6 and P, and that's why I have taken angle 4 and angle 6 over there. So now we shall write down first the last in triangle APB. In triangle APB we can say that angle 4 plus angle 6 plus angle P is equal to 180 degree. Here reason can be given, angle sum property. Okay, now 4 plus 6 have here 90 degree, as you can see in the equation number 5. So this will be 90 plus angle P is equal to 180 degree. So we can say that angle P will be also equal to 90 degree. Here we can say the reason by equation number 5. Okay, and similarly in front of angle P we may have angle Q over there, or angle R will be there. Let us see who is in front of angle P here. In front of angle P is given as angle R. So angle R will be equal to also 90 degree. In the similar way, if you go, we can say that similarly we can show angle R is equal to 90 degree, and we can say that therefore PQRS is rectangle, because all four angles we have proved as 90 degree. Okay, earlier you can see we have proved angle D and angle S are 90 degree, and now we have, angle Q and angle S are 90 degree, and now we have proved angle P and angle R are 90 degree. You can see here angle Q and angle S we have proved already 90 each, and now we have proved here angle P and angle R are also 90 degree each. So PQRS is rectangle, and that only we have to prove it. So next time we shall see the remaining 3 solved example, and this chapter will get over. Okay, thank you.